So yes, we were discussing isomers. Isomers was simply the one who has same molecular formula, but there would be a different arrangement, or we can also say same chemical formula, but there should be different structure. In that we have three types: structure isomers, stereo isomers, and optical isomers. Optical related to eyes and the lens. Not only that, but to light. Optical related to light. Okay, so structure, whereas the structure in this we just saw that there should be same molecular formula, but there should be different what, different bond other structures. Okay, so example was glucose and fructose. Glucose has the same bond, but there was a difference that in third chain number, because we have six carbon on the third, or we can also say the second last from downwards. Second last carbon would be shuffled. Like if OH is present on the right side, that would be gone to the left side, or if it's present on the left side, will go on the right side. Okay, we were discussing, and fructose have the same. So now we're discussing steroids, not steroids but stereoisomers. I'm discussing like this. So stereoisomers are many, but I will only discuss few which I feel are very much important for MDCAT as well. Otherwise, you'll find many, but I'm discussing few. In that, you'll have. I'm discussing three. In that, even two are very important. First is Anito, Anitomer, if I'm not pronouncing wrong. Okay, the second you were having is known as diastereomers. Diastereomers. I know that stereo, the first one, which is in this, you'll find that there is mirror image always. Mirror image means what? Let me just tell you. The example I just taken a screenshot. Okay, so this is enantiomer and enantiomer. So what was in this? In this you'll find a mirror image. Mirror image of what? Like mirror image is always opposite. We know that. Opposite. Okay, so this first group is attached CHO. Like this is aldehyde group. This would be attached with two oxygen and one carbon. One carbon which will be attached by two oxygen and one hydrogen, but we've written directly here no bond have been shown, but this would be aldehyde as we have two types, aldehyde and ketone. So mirror image means there is no, like there will be a position of what? We've taken example of glucose. Both are glucose, but they're opposite. For suppose I've just placed a mirror in the middle. In the here you will see a change. What change? Here you will see that OH group is present on the right side. This is right side of me. I hope this should be right side of you as well. And H is present on left side. But here it got shuffled. You see that here these both become the same, and here these are opposite. Like again, okay. This should be clear till this. Then what you are supposed to discuss. So I will just write very important point. Whenever you see O H OH OH, which would be present on the right side. When it would be present on the right side, you will call this as a D, the capital D. These are the isomers which I just discussed. We have like L and D isomers, alpha and beta isomers. But whenever you see OH group which is present on the right side of what? Right side of the chain, we are discussing glucose example. So this is right side for me. So I'm just explaining accordingly. So you find this is a D glucose, whereas when you find OH on the left side, that would be known as, that would be L. So here this would be known as L glucose for me. But now don't think that if it's right side, why isn't there R? But just think accordingly. This is a, by the way, this is a trick where you can learn very easily. You can learn very easily because where you see left, this means first word is L. So you can learn accordingly. Like when you see left side, this means there's a position or OH group would be present on the left side. When you see right, there would be D. This is a easy way, by the way, to learn. Okay, this should be clear.